Hey guys, so today we'll be talking on object-oriented programming languages. Okay, so let's start very quickly. I have prepared some notes. Okay, I will explain you in shortly. I have prepared this short notes so because I just want you to give the idea by definition. You can get it anywhere on the internet. So for I have built this for build this notes only to give you the basic idea what is the object-oriented programming language and why it is used so vastly nowadays. Okay, before object-oriented programming language, there was another concept which was known as functional programming language. So, what this functional programming language was? So, this functional programming language was storing there will be a file and there will be some sort of data, okay, like this is this, and there will be number of functions. Okay, now the main problem of this function language was grouping. Okay, so like suppose if a file has 100 of programs. Okay, so this 100 of programs will be a little difficult to read. Okay, so like it will have add one, two variables, add three variables, add five variables, like this kind of 100 programs I have to read one by one to match my expectancy if I match my desired output. So this was the one thing, and second was the security. Suppose, and by security I don't mean by someone will come and hack your program. That is not a relevant example. So the relevant example is, suppose I am a senior developer and I don't want some of the functions to be accessed by another developer. Or let's suppose if I am a current developer and some new developer comes in and some edit those files, so that will be quite difficult for the application. So it will be like a rewriting of code, and rewriting of code can cost you much. Okay, so this was, I hope you have understand what I mean by security. Okay, so this was a thing, and to overcome those challenges we have used this four concept which was in object oriented programming. Now why it is called object, it is because when you do a grouping of certain data members or member functions under some entity, that entity is said as object, and the whole orientation is known as object oriented. Okay, so I hope that you got where these two terms comes from, that is object oriented. Okay, let me zoom in a little bit. Okay, so you will get a clear view. Okay, I zoom. Yeah. Okay, so this is, I hope you are able to see the screen. Okay, for more better videos you can actually I speak in quite slow language. If you can understand my language, please go watch the video in 2x speed, so that way you will learn quickly and you can complete this video in a quicker way. Okay, so that was all about object oriented, where those object oriented terms come from. Now in order to gain advantages over this grouping and security, so we have this four concepts known as, first is a polymorphism. Okay, polymorphism means same name but many forms. Okay, so suppose like I have a concept known as addition. So under that concept, I can add two numbers, add three numbers, add four numbers, and five, and go on. So that is to in order to perform, in order to have so like if I start writing function like add two numbers, add three numbers, and add four numbers, that will be a quite bit of heavy work. So what I do is I will use the same name, that is add, and I will just change the parameter. So in this way I have the same name but I have changed the form. Okay, so you can see it over here. So I have same name, but I have changed all the forms. So that is that is what that is how polymorphism is achieved. Okay, so there are two main things. First one is method overloading, and second is the method overriding. So this will be going into much deeper as we go ahead. I will be explaining these two methods, these two concepts in more deep as we will go in the next video. Okay, so now let's talk about data encapsulation. Okay, now here we see, if you see in this programming language, in this functional language, so here I have written data, and here I have written here I can use this. Okay, so suppose I can here print a pi value. Okay, okay, so I can write any function, and I can, so like suppose there are like thousands of these constants, and I don't know how to access this function, how to how it is difficult for me to decide so we go through this all the 100 function and find the appropriate constant for me. So in the same case, I require some grouping. Okay, so data encapsulation provides this grouping where it binds the data. This is the data and the member function together. Okay, so I now clearly know that in my map entity, I'll be having this pi variable. So this is how you bind data to data with an entity. So that is known as data encapsulation. A simple form is that you can remember of a capsule. The capsule is an encapsulated capsule. So all the data is within that capsule. Okay, so that is how this entity act as a capsule. So whenever I want to find something known as pi constants, it is simple for me to go into this math entity, and I'll be able to mm, find this constant. Okay, so this was one thing, and second we'll talk about inheritance. Inheritance is simply meaning is reusability. Okay, so let's go to this parent child example. Okay, now whatever the parent has, the child gets it. Okay, so this is so whatever the child so I will get the whole accessibility of this parent. So this is how I can get all the child can get all the access of the parent, and also he can add on to things. So here if I want to make my property more well, so suppose the parent has a property of cars and bungalows. Okay, so let me write over here a return with height string. So just for explaining these things, I am writing here. So, so this is what my parent has. They have simple cars and bungalows. So I can use that cars and bungalows. So it's simple that whatever in India, whatever a parent has, the child do get in most of the cases. Okay, so here I can write a super keyword. So let me write so car industries. So now the grandchild, so the child gets the value of parent, that is cars and bungalows, and then the child itself builds the industry. So now if I write another class as a grandchild, and if I use this property, I will be getting industries, cars, and bungalows. So the use of inheritance. I hope that this concept gets clear because this is a very vital concept, and we will be exploring more and on inheritance, how to use it, what is the actual uses. This is for understanding purpose. What I'm showing you is this: what is an inheritance exactly? Okay, now let's talk about data abstractions. Okay, now here is an example of data abstractions. So here is an so by abstraction we mean, it means we will provide an abstract view. Okay, so by abstract view is like, suppose I am in 1940s and I have to develop a mobile application, but at that time uh, I don't know the clear functionalities of mobile. So I prepare an abstract view, okay, and that abstract view will have call-in and carry-out. So like is, suppose in 2010, I have to make a mobile. I will use this mobile class and I will override this function. Okay, so that is main concept of data abstraction. I hope you have got some idea about it. Yes, we'll be going in more and more deeper levels as we uh, a- as we go to as we go uh, as we go more lectures. So next lecture will be covering on polymorphism. So thank you guys, and please do subscribe to channel. Thank you.